Hello everyone, my name is Monika and I am assistant professor in CSC department in Maharaja Bhagat Singh University, Baddi. In today's lecture, I will discuss about the what is operating system and scheduling in operating system and memory management in operating system. So let's start with what is an operating system. So operating system is an interface between the hardware and the users, or we can say that operating system provide a path so that we can communicate with computer hardware device. Or the OS is one of the most important component of any computer system, or we can say that in any electrical device we have a good operating system. This is the system that runs the computer at its most basic level. Without an operating system, a computer is like less box. In every electronic device, we need a good operating system so we can communicate or we can do our work very efficiently. The OS is most fundamental program that run on your computer. It serves as the basis for how everything else works. Yes, operating system provide a path, or we can say that it gives a basic foundation so we can communicate with hardware device. OS are responsible for every work or any process that we give to the computer. This type of operating system, the computer has also determined what type of software can be run on it. We can install so many type of application in a mobile, in a computer. So it's all responsibility of the operating system to run it very efficiently. What is the purpose? Now, purpose of the operating system to organize and control hardware and software devices so that it can be work very flexible and it could not be predictable in any way. Yeah. So now, what is the function of operating system? The operating system manage the hardware and software resources by the users. All the resources that we give to the computer or after the processing, the result give to the users. It's all responsible of the OS. It manages it very efficient way. In desktop computer, these resources include in computer system, the processes is also known as the work, or we can say that the execution, electronic circuit, or memory management, disk space, and any other uh, apps, or we can say that any other processes in our mobile phone. That is all the functions are done by the operating system. It also provides a stable, consistent way so that user can do its work very efficiently. OS functions. OS function perform variety of functions that is determined what type of software you can install. Yes, coordinate the application running on the computer at any given time. Operating system can manage all the processing scheduling that we will discuss further in this lecture. Operating system manage all the time, all jobs, and what job will be run firstly and what job will be run after the first process. If all application is done by the OS system, and making sure that individual pieces of the hardware such as printer, keyboard, disk drive, and all communication properties in our computer system. Many devices are connected in a very different ways. So it's all responsibility of the operating system to manage all these devices very correctly and in a efficient way and in a flexible way. Allowing applications such as word processing, email client, and web browser to perform tasks in the system and reporting error. Yes, it is the responsibility of the OS to give the feedback about the errors to the user. If any error occurs, it will show the alert box, or we can say that the error message to the users so they can remove it very easy. The OS also determines how you see information and perform tasks. We give them so many tasks to the computer, or we can say that the programs, or we can say that the instructions to the computer So it is the responsibility of the OS to perform it very correct way and in a time, and it can be saved in our memory, whether it is RAM or it is ROM. So it all the processes is done by the operating system. Operating system gives the GUI interface, that is graphical user interface, and which present information about the pictures, icon, buttons, dialog box, etc. to the user. And first task of the operating system is managing the hardware and software resources is very important, as various programs complete the attention to the CPU, Central Processing Unit. Yes, we can communicate with the CPU by the operating system. First, the process we give to the computer is first we install in the CPU. After that, we will give to the operating system. In this capacity, the OS plays the role of the good parent, making sure that each application gets necessary source while playing nicely with all other applications. And second task is to provide a consistent application interface. Means the OS provide a consistent way, or we can say that the path, or we can say the mediator, so user can easily interact with the hardware, or they can understand the processing of the computer. And OS especially important if there is a lot of type of computer using the operating system. We have so many types of laptops, we have so many types of mobile phones, and each mobile phone has or different type of operating system. So every operating system has an important role which type of operating system the user uses. A consistent application program interface API allow a software developer to write an application on one computer and have a high level of confidence that it will run on another computer of the same type, even if the amount of memory or quality of storage is different on two machines. We can share a project with each other, whether they are friends or colleagues. So operating system provide a path, or we can say that a API application, so we can store our project in a memory or a different type of memory. Here are some notes about the operating system. Even if a particular computer is unique, an operating system can ensure that application continue to run when hardware upgrade occurs. And second one is, one of the challenge facing developer is keeping their operating system flexible enough to run hardware from the thousands of vendors manufacturing computer equivalents. So by these notes, the user wants to say that every computer has its unique operating system. So operating system is very responsible for all our activities that is done by the user. So here are type of operating system. So first one is RTO, real-time operating system. Second one is single user or single tasker operating system. And third one is single user or multitasking operating system. And fourth one is multi-user operating system. So let's start with real-time operating system. As the name defined as, what is real-time operating system? The activities or the processes that we give to the computer at a real time. Real time means at present time. So OS is responsible, real-time operating system is responsible to give the feedback in a real time, at a present time to the user. The real-time operating system could not be wait for the next instruction. Instruction means job that we give to the computer at a present time. So RTO typically has a very little user interface capacity and no end user utility, since the system will be a sealed box when delivered for the user. It is very important part of the RTO is managing the resources of the computer so that a particular operation executing preciously the same amount of time every time it occurs. And third one is, in a complex machine, having a part move more quickly just because system resources are available may be just as catastrophic as having it not move at all because system is busy. So by these definitions, Real-time operating system is a very little user interface. The jobs and we can say that the instructions and we can say that the program is executed in a real time by the real-time operating system. It cannot be wait for any next instruction, or it cannot be wait for the operating system that operating system already execute the first job. So in real-time operating system, the work we give to the computer, it execute at a real time. So here is some example. RTO are used to control machinery, scientific instrument, and the industrial system. So we can say that in our mobiles, the real-time operating system is used because every work that we give to the mobile, it is done at a present time. So next one is single user, single task operating system. As the name implies, the operating system is designed to manage the computer so that one user can efficiently do one thing at a time. Yes, as name defined, single user, single task means a single user can perform a single task in a single computer. There is no multitasking, no multiprocessing. Only a single user can perform a single task at a present time. At a one time, only one task is performed by the operating system. Here is an example of a mobile phone. Uh, Only one person at a one time can use the operating system. And next one is single user and multitasking. At a present time, a mobile phone is a single user and multitasking. So many tasks are performed by a operating system is by a single person at a present time. We can play the music at a one time. We can typing at a one time. We can sharing a screen at one time. So it all the task is performed by, or we can download anything at any time by our single mobile phones. We can play the audios, we can play the videos at a single time. So multi programs can be done by a single operating system, because in our mobile phones only one operating system uh, is installed, whether it is iOS and whether it is Windows and Linux and Unix. There is example of single user multitasking, Microsoft Windows and Apple Mac uh, is some are examples of operating system. And multi-user, as name defined, multi-user means multiple users can use a single operating system and multiple tasks is performed by the operating system. Multi-user means one or more users can use a single operating system, and every user has its different kind of processes, kind of jobs that we give to the operating system, and it is done by the operating system. A multi-user operating system allow many different users to take advantage of the computer resources simultaneously. Simultaneously means at one time multiple tasks is performed by a operating system. Operating system must make sure that the requirement of the various users are balanced, and that each of the program they are using has sufficient and separate resource, so that problem with one user does not affect the entire community of the user. Means what they want to say that is operating system is responsible for all the resources that a user want. Means if I give a task to a operating system, or we can say that to computer, so it is the responsibility of the operating system to resolve these jobs or execute these jobs at a respective time. We are not responsible for the resources and any other things. It is all the responsibility of the operating system to give the resources to the user as per the user demand. Here is a Unix, BBMs, and mainframe operating systems are some example of multi-user operating system. Now, what is scheduling? As a name defined, scheduling refer to the way process are assigned to run on a available CPU. Scheduling is a process, or we can say that a very important part of the operating system, so that multiple programs that we give to the computer has its own schedule to do the execution and to save in the memory and give feedback to the user. This assignment is carried out by the software known as the scheduler. Our programs, or we can say that our jobs can be done by the, or executed by the, or finished by the, and saved to the memory by the scheduler. Type of schedulers are long-term scheduler, mid-term schedulers, and short-term scheduler. So first one is long-term scheduler. It is also known as the admission, and what it is responsibility, decide which job or processes are to be sent to the ready queue. There are some phases in the operating system when we give a job to a computer. We can say that a process to a operating system to execution. So scheduler, long-term scheduler has a responsibility to send the job to the ready queue. It is the first step before the execution. So our first job is placed in the ready queue. So long-term scheduler has the responsibility to get the job in a ready queue. The process is an instance of the computer program. A computer program itself is just a collection of instructions, while a process is the actual execution of these instructions. After the process we give to the computer and it will go to the ready process, and after the queue line is waiting processes. Uh, so many processes are running on a CPU at a one time. So whenever the new job is come to the operating system, it will stay on the queue line. So long-term scheduler, it is, that is when an attempt is made to execute a program, its admission to set the currently execution program is either authorized by the long-term scheduler. First job will be executed, after that the next job will be ready to be executed. Here, long-term scheduling is also important in large-scale systems such as batch processing system, computer cluster, supercomputer, and render farms. So we have so many type of operating system. First one is batch operating system. It creates the batch of the processes, and the supercomputer, it is very large type of operating system that execute our performance, jobs. So type of operating, next type of scheduler is mid-term operating system. Refers to as swapping out or swapping in. Which job will be execute first, or which job have to be baked for the next time, because a job has a based on the time. How which type of job taking a much amount of time of the operating system, and which job is executed first, and which job is executed will be last. So it's all the responsibility of the mid-term scheduling. And swapping out means the job is let out from the CPUs, and swapping means new job is to be given to the operating system. Mid-term scheduler present all system with virtual memory. Temporary remove process. We have two type of memories in our computer system, RAM and ROM. So jobs after the execution will be stored in the virtual memory, or we can say that temporary memory, or a permanent memory. And next one is short-term scheduler. It is also known as dispatcher. Decide which of the ready memory processing are to be executed. Which job is ready to execute is done by the short-term scheduler. It makes scheduling decision much more frequently than the long-term or mid-term scheduler, because a decision will be made after every time slice, and these are very short. Every job has its own scheduling time, how much time they will take from the CPU whenever it executes. So it time scheduling will be done by the short-term scheduler. The scheduler can be primitive. Primitive means characteristics of security sometime before someone else. It could be safe and secure. And next one is very important, memory management. As you all know, we have two type of memory, that is RAM and ROM, permanent memory or temporary memory. So here is the type of memory management. We have physical memory, segmented memory, page memory, memory allocation, and the heap memory. So next one is allocation and protection. It is the main part of the operating system to protect our data in a safe mode and allocate the memory of every job, whether it is permanent or it is non-permanent. So next one is swapping. As I was tell you before, swapping is a process that can swap temporarily out of the memory to a backing store and then load back into the memory for continued execution. It means whenever a process is in a wait, so memory can be given to the next job. So after that, when the wait is over, the job wants to a memory to be stored. So it is the process of the swapping, which type of job can be executed, which type of job can wait, and which type of job is dead. So memory allocation is done by the swapping. And we have backing store, rollout, rolling store, and here uh, swapping out and swapping in DVD in the swapping mode. So backing store is fast disk large enough to accommodate copies of all the memory image for all the users. Must provide direct access to these memory images. Swapping provide a image processing so that we can store our job in the memory. Here are some view of the systematic view of swapping. Here is operating system in our main memory and backing store. One process is come to the store, backing store, and process 2 is swapping into the user space in the main memory. When the processing is done by the CPU, it will be stored in a permanent way. So it is swapped in. Swap in means the process 2 is now permanently stored in the main memory and new process is come out from the swap out way in a backing store, and it both are stored in a temporary and permanent way. Means process 2 after all the execution are stored in main memory for permanently, and swapping out means process 1 is stored when the execution is running. So it is stored in a temporary way. Whenever the process is complete or process 1, it will store in a permanent way in a main memory. So next step is paging. Paging means we have two type of memory, logical memory and physical memory. We can frame our memory, or we can say that we can part our memory in a some way, so that whenever the new processes come, they can store data in any pages. So we can find in paging, we can find that the how much memory is left and how much memory is executed and which type of memory is located by which kind of job. Or we can say that paging is a logical address space of a process can be non-contiguous process is allocate physical memory whenever the latter is available. Non-contiguous means the processes can be stored in any frame or any part of the memory. It's like uh, page 0 or page 1 or page 2 and page 3 are page 0 in one frame and page 2 is third place and page 1 is fourth place and page 3 is seventh place. There is no any continuous type of data. And divided physical memory into fixed size block called frames. As I told you further, this is our memory and it is divided into the frames. And next one is divide logical memory into block and size called pages. Keep track of all the free frames to run a program of size n pages, need to find n free frames and load program. Set up a page table to translate logical to physical address means to permanent to temporary to permanent address is internal fragmentation. And next one is address translation scheme. Address generation by the CPU is divided into the page number and page offset. Page number means used as an index into a page table which contain basic address of each page in physical memory. Here, frame 0, 1, 2, 3, 4, 5, 6, 7. It is the example of the page number. And page offset combine the basic address to define the physical memory address that is sent to the memory unit. Here are the page offset, page 0, page 1, page 2, page 3. These processes are done by the operating system. So that's all for this. Thank you so much for watching this video. Thank you very much.